Hello, welcome to this new video of this series. We are trying to study in depth some topics that are evaluated during the PE exam. So we are preparing for the PE exam. The PE exam is offering many different disciplines, and we are specifically speaking here about the PE structural. So in this video, we're going to be calculating the design strength of a connection. Specifically for this kind of connections we have in this drawing here. So let me try to put in yellow everything I'm going to be talking about. So I made this is the second time I am recording this video, and it's so funny because I did it the first time and I had some sort of issue with my mic, and I didn't record the voice. So I had two options: either to make a voiceover on the video that I already recorded, or just made a new one. So I decided to just record it again because that way I can just review at everything, right, and check everything one more time. So yeah, we have an element here. So this is let's say a column or whatever vertical element it is, and it's connected this other element. We don't have any information about those elements. We only are asked to design to basically is determine the design strength of a proposed uh, connection that is welded. So we know that there's a tension force, and we know also that the welding is a type of fillet weld. It's in tension. This is the graph. We know also the material of the welding is an electrode E70, and we are going to be using the AISC manual. So we have two sections in the AISC manual that can be considered as very useful to calculate the design strength of a welding connection. We have the specification, the specs. The specifications are in section J of the manual, and then we have a section, not the specs, but the section that is related to connection design, which is in the manual too. So we're gonna look briefly to those two sections. I already to make things just easier, I already paste here the sections that I'm talking about, referred. So the specs, for example, these are the specs. So in specs, we are talking about section J, and specifically related to strength. We have different definitions. So we have like the base material. So the base material will be like the material of the elements, right? We are welding, and then we can check that is what it's refer this the base material. So this equation J22 is referred to the base material, and the other part of the joint, let's say, is the weld metal, the welding material. So about this we know is E70, right? So this is considered on equation J23 from the specs, right? So let's go a little down and check what the specs says about it. So we have basically two things. This is the strength, the value of the strength, the design strength for the weld metal, this value F is referred to, let me make this a little bigger. This is referred to the material, right? Nominal stress of the weld metal in KSI, right? The one that I have in blue here. And this A is just the effective area of the weld in square inches. The effective area of the weld and the nominal stress, right? Nominal stress of the weld metal. So basically those are the two values. There's a modifier here. This modifier depends on the value of theta. So we have a theta value here. And so what is this modifier talking about? When is this applied? So it says for fillet welds, the available strength is permitted to be determined accounting for a directional strength increase. So this directional strength increase, let's say factor, or as I call it here, a modifier, is calculated using this equation: 1 plus 0.50 sin to the 1.5 power of the theta angle. So yeah, so this is something that we need to take in consideration. So when do we use the modifier? It's a question that I thought about. When do we use the modifier? So for this, we need to go to our graph, analyze our graph, and we're gonna take a look at this in some particular things about this connection. So like, for example, we have this black line. Let's make it red. So this is the welding, right? This is the welding. This is the fillet welding. And the fillet welding, it has its around, it has a length, right? This, let's say this is the axis of the welding, right? So this is the axis of the welding. So it's the this vertical line I just draw. And then we have the force, this tension force we have been given. This has other line of action. So there's another line or axis that is related to this tension force. So between the line of the axis of, or the axis of the welding and the axis of the force, we have an angle. So I just draw here the force, the tension force, the welding, and the axis of the welding, and then we have an angle there. We need to calculate an additional modifier value. This formula says the design strength is equal to the FNW, which is referring here to the weld metal, the metal we are going to weld with. And in this case, this is a thing that we have been given. In real life, you need to choose this type of electrode. Let's say, right? This kind of material we need to choose depending of the kind of material that the connected elements are. Like, for example, if it's a steel A36, for example, if it's a different kind of steel, right? So depending on the material of the steel, you need to choose the value of F, right? So in this case, it's a given. This is not a real life problem. This is just a problem for a test, and they gave you this value, so it makes your life easier. So the E70, right? We know the E70 XX. In reality, this value is the stress of the welding. In this case, it's the 70 KSI, right? That's a given. And then we have the other element in this formula, which is the effective area of the weld in square inches. This is the O, right? The AWE value. And then, so this is pretty clear, straightforward, but here we have something that we need to figure out. So let me take a pause here and show you what is AISC referring to when it says the effective area of weld. This is the material that we are depositing, that we are using to join, to put together these two plates, right? And then we have here an effective weld length, the length of the welding, and then we have a weld face. Then we are what we call the throat area. This is the shaded area. This is the shaded area, and this shaded area is calculated. So now we are on section 8 of the manual, and we have the design considerations for welds, and then we have the available strength here. So this is referring again to specification on section J24, section and table J25 of the, and also is talking about the design guide 21, welded connection, a primer for engineers from Miller. So the AISC design guide 21 is something that you are not going to have on the access on the exam. However, here they are extracting a little portion of this, and they gave you a more digested equation to calculate the strength, the available strength. So we have here one, we have 0.6 times FEXX times square root of 2 divided by 2 times D divided by 16 times L. So we're going to do this equation that we had is going to become this other one, more complex one. And then we know if we have these two elements, we are talking about this area, right? We just look at the original drawing there. So the other thing we need to do right now is just to see what value is what, right? In our case. So we have the 60, 0.60, we have the FEXX, we already said that is the 70 KSI. We have, well, this value is constant. We only need to figure out these two values. D is referred to the welding, right? And so we are asked to use 7/8, right? 7/8. So 7/8 of an inch, but we need to put that in 16ths. So that means it's 14/16. D is gonna be 14 in this case. And we have the L value, which is just the 8 inches, the length of the welding, right? So we just plug and chuck 0.6 times 70 KSI times square root of 2 divided by 2 times 14/16, the weld size in 1/16 of an inch, times 8 inches, right? So that's equal to 207.88 kips. So this section 8.1 mentioned that we have to affect this result, the results of this formula. We need to affect that for a value of P equals to 0.75 if we're designing using LRFD, or the omega value of 2 if we are using ASD. In this case, we are using LRFD. So we are going to multiply this value by 0.75. This is the phi value, right? So 0.75 times 207.88 kips is going to give us 155.92 kips. So that's the PRN, or let's say the available strength of this welding. So we need to notice something here. We have not taken into account, we have not considered yet the modifier we have been talking about. I'm going to mention one more time here. We have a force, we have the line of action of this force, and then we have our welding or fillet welding. The fillet welding, this fillet welding, it's acting with respect to the force with an angle, in this case is 90 degrees. So we need to calculate the modifier. So the modifier is calculated using this equation. 0.5 times the sine of 90 degrees to the 1.5 power plus 1, right? So this is equal to 1.5. So that means 50% additional capacity if we have an angle there. So the final value is going to be 1 times 5 bigger than the affected by the phi value, right? The reduction. So it's going to be 1.5 times 155.92. That's going to be equal to 233.88. So approximately 234 kips. So hopefully, if we have in a test scenario, we have different values. Let's say A, 120 kips, B, 156 kips, C, 200 kips, D, 234 kips. Then we know that the closest value to that one is the 234. So then we will just check this one and get our point. So hopefully this helped you to get a better understanding of the process to check for a to check the design strength for a welding joint in tension. You know, some problem like this we are looking at. So I have been using reference. I'm taking these problems from many different sources. I'm gonna write down in the comments on the description of the video. I'm gonna write and share with you a link to the book that I've been using to illustrate this problem and every problem, you know, as they come from different sources, as we continue our journey into studying and to making this review for the PE exam. So thank you so much for your attention. I hope to see you soon in another video. If you enjoy this, if you think this is a material that is useful for a friend, for somebody who is getting ready for the exam, just please share with your friends. Like, subscribe for more videos. See you next time.